Thank you for joining me. I'm glad to have you there. I want us to look at the alternative to physics practical questions. Remember in our previous video, I gave us the various areas where questions are coming from. Now today, I want us to look at one of those aspects, which is mechanics. Now in mechanics, let's see how the number one question is solved. Other videos will see solve other questions. So stay tuned. Let's solve it together. Okay, this is question number one. You can see the diagram there, and we can see we have this, we have this. Now the question says, an object Q is released from a height and allowed to fall freely onto a vertical spring of natural length L0, as shown in the diagram above. As shown, this is the length as shown. Now they said the length L of the compressed spring was recorded, and the height h of the object above the spring was also recorded. The procedure is repeated with the object falling from the same height. The whole procedure is repeated for 4 other values of height. In each case, L is measured twice. Now from here, we now have figure 1 shows length, shows the heights hi. Of course, this I is just an integer that from here now have I is equal to 1, 2, 3, 4, 5 respectively. Now they said the height of the object above the spring balance, while figures B and C are scale diagrams of the spring showing the compressions L, compressed length please, Li, for the first and the second readings respectively, where I, they have repeated where they have told us here, this I will have here, and this L that has I here, will have that they are from 1 to 5. Now this is the length, and of course this is a figure 1. We have from A to B as our H, figure 1A. This is a height of mass. Now AB represents 4.5 4.5 meters, and of course if you check here, we can have this 4.5 meter. This is the 4.5 meters. Okay. Now we have, this is the first reading, and this is the second set of reading. Of course, this is the L. Now this is H is constant from here to here. H is constant. Of course, it's scaled. Okay. Now let us continue. Now from here we have AB represents the maximum height, Hi equals, H1 equals 4.5 meters of the object above the spring balance. Deduce the scale of the figure and use it to determine and record the values of H2, H3, H4, and H5. Measure and record the corresponding 2 sets of L. That means L is going to be 2. The first set and the second set, just as I showed you earlier. Determine and record the value of L in each case. Now question IV. Evaluate L is equal to L naught minus L mean. Now this L mean here, of course, it is the first set of L and second set. You now take the mean of L1, first set and the second set. That will give you the mean. And of course, this is what we usually do in the laboratory. In each case, evaluate E squared. So if we get E, we're going to get E squared. Tabulate your readings. Question VI. Plot a graph of H on the vertical axis against E squared on the horizontal axis. VII. Determine the slope of the graph. VIII. From your graph, deduce the compression that would be produced when the object is dropped from a height. 3.6 meters. Now, the next one says, take 2 precautions you would take to ensure accurate results if you were to perform these experiments in the laboratory. Okay, let's start up immediately. The scaled diagrams we have are, we have this, which is our head, A, B. We are going to measure it. Now, and of course, from here, we are going to deduce our scale from here. Now, how do we deduce our scale? Since from measurement, we have from here to here, we measure it. And from the diagram also, they said from here to here represent 4.5 meters. Now, what it means is that we measure from here to here, whatever it gives us in cm, we'll equate it with this value we have here. And then from here, we divide it. In fact, all we need to do is the simplest form. Since this one is in millimeter, this one is in cm. All you need to do is to convert it to cm. And of course, if you convert it to cm, we will have 450 centimeter. Now, we take measurement. By the time we measure the length from A to B, make sure, now if you take our measurement, we can now see that, yes, make sure it's placed properly. Now, if you now place it properly, that means the length AB is equal to, and of course from here, we can have 5 here. This is 5.5, 5.6, 5.7. So AB is equal to 5.7. What we'll do now is to, so since AB is AB, the length is 5.7. The length of AB is 5.7 cm. Now, what we now have is that from our scale here, we say we have a 450 cm is equal to 5.7 cm. So this thing is equal to this. How do we get 1 cm? Therefore, 1 cm is equal to 450 all over 5.7. And if we press that in our calculator, it will give us that 1 cm it will give us 78.95 cm. Therefore, we can conclude that 1 cm represents 78.9 centimeters. So this is our scale now. So what it means that whatever we obtain, we are going to multiply it with 78.1 centimeter. And of course, given all these values we have here, all we need to do, because we are going to take our readings for H, we are going to take our readings for I. Sorry, we're going to take our readings, yes, for L, of course, L1 and L2, and L mean, because L mean is the average of the first set and the second set. We're going to take for H, we're going to take for E, we're going to take for E square. So the first thing we do is create columns for each of these parameters, and then we'll come up with the table, and then we'll start to fill it up. So let's go there. Having created our table, now the first one, like I told you in our first video, we'll create column for H raw, we'll create column for H converted. Now H raw is the exact value you get. The H converted is the one you get after conversion. Now we have our first set of length. We have the second set of length. please ensure that each of them has its own SI unit. Now, L mean, which is in cm. Now, remember the extension is just E naught minus, sorry, L naught minus L itself. Now, from our diagram, we have that L naught is 6 cm. So whatever extension we have, we subtract it. So the whole length is just from here to here. Now this is the extension. So once we measure, it is expected that we subtract the L naught from it. Okay, so let's go there. Now at the end of the day, we'll now get our values for E squared by evaluating. So let's hit it. Now the first one we are going to take is our H1. H1 we measure from here, and of course let me use down here. You measure the H1 is from here to here. So we make sure you are placing your ruler very well. So we measure from here up to there. So which will give us that H1 from, if you read it very well, H1 is of course the length, which is 5.7. We note it down. So 5.7, we write it H1 5.7. And of course, like I told you, every measured value must be written to at least 2 decimal places. So we now put 0 here. Now we move down again to take our H2. H2 will start from here, and then of course from here now H2 will give us this is a 4.5, 4.7. So we write whatever we have. So remember, you are going to measure it correctly. So we have here 4.7. You put 0 at the back. Now we still go back again. If we go back, we measure, place it properly. We measure for H3, and of course H3 is 4.0. This is our H3. So this one is H1, H2, H3, 4.0. Now let us take all the measurements at the same time. Now this one is 4.0. We notice somewhere 4.0. Now this one is 3 here, 3.1, 3.2. It is 3.2. Now, after that, we take measurement of the last one, which here is 2. It's not up to 2. 1.9. So we record those values. Now, the first one gave us 4 either you can write 4.0, can write 4.1 because it was not exactly at 4.0. Now, if you write 4.1, it's still something. 4.0 is still something. Now, the other one gave us 3.30, and then the last but not the least gave us 1.90. Okay. Having gotten this, the next thing is to convert. Since each of them gave us, from what we solved here, our 1 cm represents 78.9. So all we need to do is multiply each of these values by 78.9. And if we multiply that, we are going to get, for this first one, 5.7 times 48.9 will give us 450.02. Now, if you multiply the other one, 4.70, if you multiply it by 78.9, 9, we are going to get 371.07. Multiply this one, you are going to get 323.70. For this one, if you multiply this one, we'll get 260.54. Now, the other one, if we multiply 1.90, if we multiply it by 78.95, it will give us 150.01. Now, the next thing is we have left is our L1 for the first set, L1 for the second set. Now, for the second one, this is we place this properly. If we place this automatically, the first set L1 is giving us 3.0. Yes, this is 3.0. Now we can still measure this one first. This is the first set, this is the second set. We can still measure it. Now if we measure this one will give us 3, it's up to 3. This one is giving us 3.1. Yes, this is 3.1. First one is given us 3.0. This one is given us 3.1. Now we measure for L2. L2 is giving us 3.1. L2 is giving us. Now L2 for the second set is giving us 3.25. Now if it is giving us 3.25, now the second one, the third one, will give us, start from 0 here. Now which one is giving us 3.567. Now 3.7. Now if we come down here, this one is giving us 3.6. Okay, we'll take L4. Is it L4? Now L5 now. If we take L5 will give us, for the first set, it will give us about 3.9. Now the second one will give us, this is 0. If we place it properly, we are going to have almost the same thing, 3.9 of 4.0, please. 4.0. Now let us add up everything. Watch your screen. Everything is displayed on the screen, please. Okay. Now we have completed our tables. Now from the first and the second set of spray measurement, we take the mean. Of course, 3.0 plus 3.1 divided by 2, that is the mean of these two, will give us a 3.05. The same thing, the 3.2 plus 3.2, the average of this 3.2 will still give us 3.2 down the whole thing. Now for this column, of course, this is extension. Extension is, we have the original length L0. L0 was given to be 6 cm from our diagram. Of course, this is our diagram. L0 is going to be 6 cm. So here now, the extension will now give us 6 minus the L. For example, the L we are using now is the L mean. 6 minus 3.05 will give us 2.95. 6 minus 3.2. Please pay attention to the instructions given to you. So 6 minus 3.2 will give us a 2.8 down the whole plane. Now the extension 2.95 squared will give us 8.703. Now emphasis, we need to emphasize on this. If you are taking measurements directly from device, such as the meter rule, which we have used now, you are going to record it to at least 2 places of decimal. But if it is evaluated value from the calculator or from 4-figure table, please record to at least 3 dp. For example, this one that is a square of this one, which is a 3, we'll record by 3 places of decimal. If we will take, for example, sine of a number, log of a number, tan of a number, we are going to write it to record it to at least 3 decimal places. That is why we have this. So if we take the square of all these values we have, it will give us these values. Now, the next thing is to plot our graph. Now, the whole thing says, plot a graph of h on the vertical axis against e squared on the horizontal axis. From there, we're going to determine the slope and do the necessary deductions. So let us plot the graphs. Okay, now we have the table before us there, and the next thing is to plot. Now from the question says, plot a graph of h against e squared. The first thing we'll do is label your axis very well. So we are plotting a graph of h, and of course h is in centimeter. You put it there against our e. So here you put your e. You are plotting a graph for e squared. Now e squared is in centimeter squared. You indicate it. On no condition should you fail to do that. Now, after indicating your axis, the next thing we'll have is here, because we are starting from the origin. If you are starting from the origin, please indicate it as 0, 0, meaning that the horizontal axis xy starting from 0, and while the vertical axis is starting from 0. Now, looking at the values we have there, of course, the highest value we can have on the h-axis is 450, and of this, the scale you will choose is highly dependent on the values you have. Now, I can have here 100, 200, 300, 400, and I can have here 500. Continue. Finish up the 600, but then 700. Remember we said in our first video that your highest value should occupy at least 2/3. My highest value is 450, so it's not up. It's more than half of our graph sheet. So this is our full graph sheet. Now, having done this, it means that from here to here is 100. From here to here is 100. That means, and then how many lines? How many divisions? 1, 2, 3, 4, 5. So 1, you don't count this one. This one is 0. 1, 2, 3, 4, 5. That means 100 divided by 5. It means that each line is 20. So we now have a 0 here. Sorry, 0 here. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, in that order. Now, on the e squared axis, the highest value we have is 8.7. And if we should take 1, 2, 3, 4, 5, 6, 7, 8 to not be accommodated here, in other words, we are going to shorten it. We can say, of course, from your graph sheet, you can say, let this place represent 2. So, if this place represents 2, we can have 4 here, 6 here, 8 here, 10 here, 12 here, 14 here. Please, where your highest value ends, don't just stop there. Ensure you label to the end. Okay. Now we start. So what it means is that since here is 2, it means that we have here as 0. If we say here, that means 0.4 here, 0.6 here, 0.8 here. No, sorry. We divide 2 by 5. So if we divide 2 by 5, we'll get 0.4. Yes, we have 0.4 here, 0.8, 1.2, 1.6, and then 2. So that is what it means down here. Okay, now we plot the first one. The first one is 450 against 8.7. 450. We have here is 400, 410, 420, 430, 440, 450. No, 450 somewhere here. So we have 420, 440, 460, 480, 500. So 440. We have 440 here. This here is 440 and here is 460. That means we will plot in between somewhere here. That is where we'll get our value. So now we note that point. So if we note that place, the next one is 8.7. Remember, here is 8.0. The next one is 8.4. 8.8. Now the value we have is 8.7. So we can have here, and of course here the first line here is 8.4. Now if we plot 8.4 here, it's not up to. Now if we plot here we have 1 point, so we can plot in between. So in between now will give us somewhere here. So we'll plot somewhere here. We'll plot here. Okay. Now, if we plot here, that means it has exceeded. So we can reduce it here and plot inside. We'll plot inside here. Now we'll take the next one. The next one is 371. Now because 371, we can only plot 370, or we move it. Now this is 300 here, 320, 340, 360. Now the next one is 380. So of course, so is in between. So we note in between there, somewhere here. Now the other one is 7.8. Now this is a 6.4, 6.8, 6.8, 7.2, and 7.8 on this line. So 7.6 please on this line. So we can now plot somewhere here, which is 3. This is a 370. 370 is in between here. So we can plot somewhere here. So even if we plot it here, okay. Okay. We'll have it here. Okay. Now we have the next one. Now for the third one, we are plotting 323.7 against 7.0. Now this is 320. So 320 somewhere here. You can plot, because it's not up to 320, it's not up to 340. You can plot 320 or a little bit above 320. You trace it down up to here is 6.2, 6.2, 6.8. Now we are plotting 7.0. This is 6.8, and the next line is 7.2. because of that, we don't need to get to this point. We can take it at this point here. We can take it at this point. So if we take it at that point, we can have the next one. The next one is a 260. 260. So this is 220, 240, 260. So 260, you trace it down to 5.5. This is 260. You can trace it down here. This is a 4.2, 4.4 here, 4.8, 5.2, and then the next line is 5.8. Since it's 5.8, is between 5.8, we have 5.5 between this one and this, so we can have it at the middle here. We can have it at the middle here. Now, the next one is 150. Now remember, this is 100, 120, 140. So this is 120. So between 100 and 120, you can have it here. You trace it down to 4.2. This is 4.0 here. This is 4.4. In between. Now, since it's in between, and this line is 120 here, so we can have it somewhere here, in middle of the box. Now, having plotted our graphs, the plotted points 1, 2, 3, 4. So we can now draw our line of best fit. Now, our line of best fit will give us, we'll have, remember we said if we are to now for our line of best fit, we get a longer ruler. Remember we said you must get either 2 points or 3 points. But now we have five plotted points, this and this. Now if we take these two, it will not work because we'll only get 2. 3 will be on the down. Now we can take, if we can get these 2 now, that means these two will enter, this one will be off, the other one will be off. So in other words, we can take it off from here. So if we take it off from here, we can now have here as our line of best fit. So if we have this as our line of best fit, so make sure it is moved. Now, since we have this as our line of best fit, taking care of 1, 2. Now, of course, since 2 enters, it's either 2 enter this way or 1 below the line. Now, the next thing is to draw our slope. Now, we can take our slope from any point. From any point, slope can take any point. We can take from here. If we take from here, we bring it down. We can bring it down up to this point. Up to this point. So if we can get it up to this point. So, now sorry for that, we'll take it up to this point to give us something like this. So we now have our slope is triangles from here to here. Now since it's from here to here, we can make a mark here showing that this is where it is. Use arrow here, use arrow here, and at the same time we can still make another mark here to show us that yes, we are reading from this point, we're reading from this point down to this. So we can label here as change in H, while here is our change in E squared. Now, once we have this, the next thing now, please, this is the best you can do on the graph sheet. For us to work out our slope, we will do it on another sheet. However, but for the benefit of this lesson, I will do it here. But please, if you are working out your slope in the main exam sheet, please work it elsewhere. That is position for it. Do not work on the graph sheet. So, because I needed this graph sheet to work out my slope, I have slope is equal to change in h all over change in e squared, which will give us that here we have whatever we have here. Remember our slope, the triangle started from somewhere here, so we reach here down. So if we read it here, this is 600, 620, 640, 660, 680. So we have here as 680 minus what we have here. This point, you trace this point, which is 300 all over. Now, for the change in e squared, what you have here minus what you have here. So this one, you trace it down here. And of course, this is just 1 point before 12. Of course, this is 10, 10.4, 10.8, 9.2, 9.6. So we have here as 9.6 minus what we have here. Now, if you can trace this down, this is 6.4 minus 6.4. Now, if we employ our calculator, we can have that our slope is equal to 680 minus 300 will give us 380 all over 9.6 minus 6.4 will have 30, we have 3.2. Now 380 divided by 3.2, it will give us 118.8. It must have SI in it. The SI in it will now be whatever you have here over what you have here. And of course, here is cm. This one is in cm, please. What is one in cm squared? Now, one of these will cancel this. This one will cancel one of this, and we'll have this remaining. Therefore, the SI unit is per cm. 118.8 per centimeter. So that is our slope. Now the next question is question VIII. The question says, from your graph, deduce the compression that will be produced when the object is dropped from a height of 3.6 meters. Now, from a height of 3.6 meters, they said the extension that will be produced. Now, all we need to do is convert this to cm because the height is in cm. If we convert our height to cm, it will give us 360 centimeters. Now, what you need to do is go to h axis, deduce 360 cm. Of course, this is 300, 320, 340, 360. Now, what we do is, since we have 360 here, trace it down to E column where it touched the axis, where it touched the. So this is where it touched the line of base fit. Now, from here, you can trace it down. So, if you are given such a question, what you will do is, this is 320, 340. From here, you can use dotted lines. Use dotted lines to note it. So if you use dotted line, where it meets your line of base fit, from there, you can bring it down and reach the value. So that is, it is somewhere here. So this is the point. So when the height of the material is dropped to a height of 3.6 meters, the extension that will be produced, or the compression that at that point will now give us, this is 6.4, 6.8, 7.2 cm squared. Therefore, the answer there will be 7.2 cm squared. So that is the answer to this one. Now, the next question here says, which is the last but not the least. State 2 precautions you will take to ensure accurate result if you were performing this experiment in the laboratory. Yes, remember in our previous video, I gave us the necessary precautions to be taken. Since one, there is a meter rule. Meter rule was used in the experiment. One, I ensured that zero errors was avoided, or you can say that yes, I noted and corrected zero error of the meter rule. That is the first one. Next one, you can say that I avoided error due to parallax while taking my readings from the meter rule. And of course, like we said, we read directly. We don't read by the side. That is the error due to parallax. So I avoided error due to parallax. You always use the personal pronoun I. Now, the next one is that since of course, most times we do it when there is we can avoid drought. Of course, drought is a situation where there is no air interruption. Okay, you can always say that I ensured that spring is vertical. While performing the experiment, you don't keep your spring. And of course, from here, the spring is vertical. So we ensure that the spring is kept vertical throughout the whole experiment. Next one, you can say that I ensure that object is dropped along vertical axis of the spring balance. Of course, the spring balance is calibrated vertically. So you drop objects vertically, don't drop objects horizontally. Now, the last but not the least, from our table, because we have L1 and L2, we can also state that I ensured repeated reading to avoid systematic errors. I ensured repeated reading as shown in the table. So you should as well make notes of that, make reference to that table. I ensured repeated readings as shown in the table. So these are some of the questions that will be given to us. Now, the last but not the least, a question was asked somewhere there that extreme balance of force constant 300 Newton meter per second is compressed such that its length is shortened by 3 cm. Calculate the energy stored in the spring. Now, if you are calculating the energy stored in the spring, now I can turn this and then use the back. Now, if I should use the back, now remember here they gave us a straight balance of force constant K is given to be 300 Newton per meter. It's compressed so that its length is shortened. Now, when its length is shortened, that is the extension is shortened by 3 cm. Calculate the energy stored, and of course, energy stored is half Ke squared. Now, since this one is in meter, this one is in cm, all we need to do is get the two of them to be, of course, 3. If we convert 3 cm to meter, it will give us 0.03 meters. Now, we will now have energy stored is equal to half times E squared, half times K, which is 300 times E, 0.03 all squared, which will give us half times 300 times 0.03 squared will give us 0.03 squared will give us 0.0009. Now, this times 300, which will give us half times 0.27. Now, half times 0.27 will give us 0.135. Now we have that joules. So this is our energy stored. Energy stored is this. Okay, thank you very much. This is where we'll end the lessons for today. Please make sure you join me in my next video, because I'm going to solve another question on mechanics. Before we now move over to, so hit the like button, subscribe, hit the subscribe button, so that any moments I drop lesson, you'll be notified and follow it. And I'll at the same time put the link to the previous video in the description button down below. Thank you very much.